Hey everybody, Miss Maritello here. I wanted to talk a little bit in this video about the determinant of a matrix. This goes along with task 8-9 from the MVP Integrated Math 1 curriculum. So in this task, they ask us to find the multiplicative inverse of a matrix. And they're asking us to use the process that we did at the end of task 8-8, which I've outlined in another video on my channel. If you go through and do these for number one, essentially I'm not going to go through the whole thing because I do it in another video with a similar matrix, but essentially when you multiply the two matrices in the equation that you would be looking at, you're resulted with two systems. And for the first matrix that they give us with number one, you're able to go through and solve both of those systems, and then you're able to find all the variables that you would need to write the inverse matrix. And it works out pretty well for the first one. However, when we go to the second problem, which is number two, when you start to go through the same process, you're going to see that for this one, when you go through the systems, and feel free to pause it if you want to take a better look, but when you go through the systems, you're going to see that the first one is going to come out to be no solution. And if you go through the second video, the same thing's going to happen. So then we should be realizing that because we're getting no solution, that second matrix in number two, there actually is no multiplicative inverse. So the third question asks us, were you able to find the multiplicative inverse? Well, no, only for the first one. Second one, the system came out to be no solution. So hopefully what we're realizing is that every matrix does not actually have a multiplicative inverse. But so you might raise the question of, well, how am I supposed to determine if a matrix has a multiplicative inverse or not? And funny enough, the task then goes into talk about this number that we call the determinant. And the point of the determinant, it's essentially a number that comes out and it'll tell us if the matrix has a multiplicative inverse or not. So if the determinant comes out to be 0, there won't be an inverse matrix or a multiplicative inverse. If the determinant number, if that's anything other than 0, then there will be an inverse. But again, if the determinant comes out to be 0, there's no inverse. And then they do a little bit of talk with notation here. So if they ever show the matrix, notice here it's straight vertical lines, whereas usually we see it with more of the rectangular brackets. If they show the straight lines up and down, that's asking you to find the determinant. And if the matrix was in this form, AB in the first row, CD in the second row, then you'd multiply the numbers AD, so this one with this one, and then you'll be subtracting the product of B and C. So that gives us the determinant, and then the determinant will tell us if there is a multiplicative inverse or not based on if the number is 0 or something else. So if you want to, you can find the determinant with those two problems. I actually want to show you guys the determinant for the matrix that we had looked at in my previous video. So if I was to find the determinant, they might show you the vertical lines up and down. It's possible then they might just say, hey, find the determinant here. I'm going to draw them the vertical lines just to use the notation. But so if you were to do that again, you'd be multiplying A times D, which is the 3 times the 4. And then you're supposed to subtract whatever B times C is. So that'd be like 2 times the -1. And we do have to be careful with our negatives here. So it comes out to be 12 minus a -2, which is 14. Now, I want to kind of show you guys, though, how the determinant kind of relates with the multiplicative inverse, though. Because even though that's great, and so we see that because we're getting 14, it's not 0. Remember that if the determinant is 0, that means that there is no inverse. But so because it's a number other than 0, that means there will be an inverse, which hopefully you would know because we found it in the other video if you watched it. But so there will be an inverse, and actually I'm just writing down what we had gotten from the inverse in the other video. But what I want to show you, though, is even though we had simplified these two fractions, say that I didn't simplify them, sometimes people see this little shortcut to find the matrix a little bit easier. So had I gone through here and I didn't simplify these fractions after I went through the system, before I got 2 over 7, I had really come out with 4 over 14. And in the same way, before I came up with this -1 over 7, if you watch the video again, before I got that, I really had -2 over 14. And then 1 over 14, it came out like that, and same with 3 over 14. But sometimes people compare this matrix, the inverse, to the original. And a lot of times what they notice is that the 4 and the 3, they almost seem like they flip-flop spaces. So now I have a 4 here, and I have a 3 here. So it almost seems like they kind of flip-flop spaces. And I still have 2 here, and I have a 1 here, but they're the opposite sign. So where I had previously had 2, now it's negative. Where I previously had 1, it's negative. But then every single number is divided by the 14. So a lot of times what people realize is if I wanted to find the inverse, if I took the original matrix and I did 1 divided by the determinant, I could multiply that by almost like the original matrix, except I'd have to switch these 2 numbers. So instead of it being A and then D, I'd be flip-flopping those. And then these 2 numbers stay in the same spot, but then they're opposites. So I actually can use this formula to go through and find my inverse matrix based on that idea. And I'll kind of just show you guys how it would work again. So say that I knew that this was my formula, I'd have to find the determinant and then do 1 over the determinant. So because I had found the determinant was 14, I would put a 1 over 14 outside. It would be like a scalar. And then if I looked at, okay, 3 and 4, those are supposed to flip-flop. So then I'd have 4 here and 3 here. And then, oh, these 2 numbers are supposed to become the opposite. So the opposite of 2 is -2, and the opposite of -1 is +1. And then I would go through and I would multiply everything by the scalar, which is becoming 1 over 14. So then this is like 4 over 14, -2 over 14, 1 over 14, and 3 over 14. And then I would just simplify any fractions that come up. So 4 over 14 would simplify to be 2 over 7. -2 over 14 would simplify to be -1 over 7. And then the other 2 numbers I can just keep. But so essentially that would be our shortcut to find the inverse matrix.